Algebra 1 students, here are your lesson 5.7 notes the first day. We will also work on this on block day and use a little calculator, but today we're going to look at scatter plots and trend lines and how we can use those by hand. So a scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. Most of the time when we measure real life data, we stay in the first quadrant. You can't have negative puppies or negative people, and so typically those types of things keep us in the first quadrant. Now we have three possibilities for data. One is a positive correlation, like you see on the first example here on the left. That's a positive correlation because as the x value increases, or one of the value increases, the other follows. The second is a negative correlation, whereas as the x value increases, y tends to decrease. So you can see, you could draw a line that would connect most of these points, and it would be sloped downward, negative slope. In the last situation, there's really not a trend that we can follow, either positive or negative, so we would just say there's no correlation, and you see that here where a change in x doesn't really help us to predict what would happen with y. Alright, when there is a correlation, whether it's positive or negative, between two pieces of data, it's appropriate to create a line of best fit, or a trend line, that allows us to predict other data points, both between the known values and outside the known data. So when it's between the known values, we call that interpolation, key being enter, in between. When it's outside the data, I'm predicting a future event, it's extrapolation, extra being the prefix. Alright, so let's go ahead and apply this. So what we've got here is a chart that shows us temperatures based on altitude of an airplane. Now what I'm looking at is, I know I'm going to need to label my x-axis with the altitude, and I'll label the y-axis with temperature. So let's go ahead and do that. I have to keep in mind where I'm going as I label this. I need to get up to 5,000 feet. So this has 10 squares. So if I count by 500s, and I'm just going to label every other one. So 1,000, 2,000, 3,000, 4,000, and 5,000. That should do the trick. And that altitude is measured in meters. Where the temperature, the max that I see here is 59 degrees. Maybe it would be okay to go by tens in this scenario, even though that's going to go a little bit higher than we really need it to. And again, I'm not going to label every single spot. I think going every couple of tick marks will do the trick. Alright, so let's take a look at this. When our altitude is 0, the temperature is 59 degrees, so we're going to estimate it right there. At 500, that's the first tick mark, our temperature is 59.2, very little difference. At 1,000 feet, our temperature is 61.3, so we've had a slight increase. At 1,500, our temperature is 55.5, so for the first time we're starting to see things moving down a little bit. At 2,000, it's 41.6. At 2,500, and so on. I'm going to go ahead and pause the video and you finish labeling your scatter plot, and then you can look at mine and compare. Okay, you can see my scatter plot now, and it's obvious that this is a downward trend. It's not exact. It's not like I could say if your elevation is 6,000 feet, what will the exact temperature be? There are obviously other factors that cause it to sometimes move a little up, a little down, but in general it's a downward trend. So in other words, as the altitude increases, the temperature decreases. We call this a negative correlation. Alright, that's number one. Moving on. Another table, this time we're comparing gasoline, the dollars spent and the gallons purchased. And I'm going to start labeling the plot again, or labeling the graph, plotting each point. So if I purchase 2.5 gallons, it costs $10. And I'm going to actually pause the video again, let you guys fill out the scatter plot, and then we'll pick it up with the follow-up question. Okay, you can see my scatter plot here. And when you take a look at this, I think it's pretty fair to say that we have a positive correlation. It's a pretty strong correlation, actually. It's very close to a line when you look at it. So we'll call it a positive correlation. Now, part B says to sketch the line of best fit. One thing to keep in mind, and this doesn't apply to every problem, but in this one there's another point that we could assume that's not listed here, and that is if you purchased 0 gallons of gas, that would be, well, $0, right? Alright, so what I'm going to do is go ahead and create my line, and it wouldn't be necessary that you include that 0, 0 point, but I just thought you should think about it as kind of our starting point. And then you can see the graph would look something like this. Now we're just sketching this by hand. We're trying to hit as many of the points as we can. So if I leave a point above, it's maybe good to put a point below. But we're just trying to go through the middle of the data. Now, the question is, sketch line of best fit. We've done that. Does this seem to be a good fit? And I would say yes, the reason being that all of the points are close to the line. You can tell that some of the points are a little above, a little below, but in general they're all very close. Okay, the next question. Predict the cost for 4.5 gallons of gas. Alright, and it's a two-part question here. Here's 4, here's 5, so we'll go halfway in between. And what I'm looking for is where it intersects with that line. So it seems to me that a good estimate of what it would cost for 4.5 gallons would be $18. Now the question says, is this interpolation or extrapolation? Again, inter means it's in between the known data points, where extra means it's beyond that. And this is clearly beyond the last known data point, so we would call this extrapolation. Alright, last topic we're going to look at is causation. Causation is when a change in one quantity causes a change in a second. A correlation between two quantities does not always imply causation. Alright, what does all that mean? Well, here are two examples. First, you have causation. The distance between two cities and the time it takes to drive between them. You would think the further apart two cities are, the longer it would take to drive that distance. And that is the cause. Driving to Gardner, Kansas from Olathe is a much faster trip than driving to Dallas. And that has everything to do with the distance between here and there. Other times, though, there are two pieces of data that have a positive or negative correlation, but one is not caused by the other. An example of this, the number of Starbucks and the number of teachers in a city. As the number of Starbucks increases, you would think, so would the number of teachers, but that really has nothing to do with the number of Starbucks. Building a Starbucks doesn't bring in new teachers, and bringing in new teachers doesn't cause a Starbucks to be built. But there's a common link between them, and that is the population of the city. As those numbers increase, the number of Starbucks would likely increase, as would the number of teachers. So they have a positive correlation, but it's not causation. In other words, one does not cause the other. So let's take a look at the examples you see below. Is a correlation likely in each of these? And if so, does it involve causation? Is there a causal relationship? And we'll explain the reasoning as well. The number of fish in a tank and the food required to feed them. It seems to me that the more fish you have, the more food you would need. So we would say yes, correlation is likely. And in this case, it's also causation because that the number of fish is directly affecting the amount of food needed. Okay, on B, a person's month of birth and their salary. As far as I know, there's no connection between these two events. I can't imagine that people born in, say, January make more money than people born in February or March or December. It doesn't matter. That's not why people get paid. So this is not a correlation. And then the last one, the number of pencils sharpened and the number of Kleenexes used in a classroom. Now it's likely, in my experience, that the more, as the number of Kleenexes used increases, so does the number of pencils that would be sharpened. I haven't specifically kept this data, but I'm pretty confident it would be true. But I'm also confident that it's not a causation. In other words, sharpening pencils doesn't cause people to need Kleenexes, or using Kleenexes doesn't cause people to sharpen their pencil. Both of them are an impact of an increased number of students in a classroom. So I'm going to say yes, a correlation is likely, but it's not causal. One event does not cause the other. All right, you have completed the video, and make sure your notes are filled out. Come ready to roll on Tuesday. See you guys.